Hey everyone, hope you are all doing great. Good morning, good afternoon, and good evening to all who all are joining us globally. I am Parthuru, Events and Program Manager for Microsoft Reactor. And yes, I welcome you all for our another episode of MVP Connect. Today we have our MVP Janardana. But before we start our today's event, let's go through our code of conduct. We are all here to learn together, participate together. So please be respectful of other people's views, understanding the differences. Be kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section and we will pick it up from there. I would not like to delay further. I would like to bring in our MVP for today's event, Janarthana. Hey, hi Janarthana,
Hey
how are you
Parth,
doing?
good Parth. What about you?
All well, all great, going good so far. It's summer,
Yes.
peak summer. Oh, yes.
And it is also the season of agents everywhere. That's a now new trend.
Seasons of Engines is a very hot topic currently, and it's trending. And so many events are lined up. Please do visit our Reactor meetup pages, also the Reactor event pages. You will find n number of learning activities going on. Yes, Janardhan, the floor is all yours.
Thank you so much for providing me this opportunity, and also thank to the Microsoft Reactor Bengaluru for one more time for this wonderful opportunity, and also whoever participants join from globally. So welcome to the another interesting episode on develop an AI agents with semantic kernel. Okay. So let me introduce myself. I am Janardhan and Selvaraj. I'm a Microsoft MVP and the AI category. And also I'm a Microsoft certified community lead for the India region, Chennai. And I'm a Microsoft certified trainer. Also, I'm a Microsoft Learn expert for the data and AI domain. So currently I'm holding 14 plus Microsoft certifications under the Azure. And if you have any questions related to generative AI or else agentic AI, feel free to reach out to my LinkedIn handle. And also, I used to post the hackathon updates, the internship opportunities, and the technology updates on my YouTube channel. So, this is my YouTube handle. So, you can do visit the YouTube channel as well, and you will be getting the updates related to technology, updates related to internship, as well as the job opportunities. Let's get started. So, what we will be discussing as part of today's discussion is around the agentic AI introduction. So, how the agents has been evolved, what is the usage of agents, and what is the major role of the Azure AI agent services, the components of agents, and we will discuss about various options for the agent development framework. So one of the agent development framework we will be discussing a deep dive with today, it is the semantic kernel, and also we'll discuss how to build your own agents using semantic kernel, various types of built-in plugin, and the usage of prompt template as well as personas in your semantic kernel. So this is about the overall discussion today. The very first topic, which is agentic AI. So the agentic AI, it is a new frontier of this generative AI applications. And also, if you want to build any type of AI system where you are going to act autonomously without having any human intervention, where human intervention will be required with a minimal basis. And also, if you want to achieve your goal centric and this particular agentic AI is going to suit for your various type of platform as well as environment. When it comes to the agentic AI, we will be leveraging all our generative AI services as well as the AI models which are available in the model catalog of Azure AI Foundry. So how this agents has been evolved over a period of time, if you notice that, it starts with the chatbot applications. Initially, if I want to build my own chat related interfaces or else virtual assistant type of an interfaces, you can build your own application with the help of chatbot. Then since the knowledge base was not up to date, you will be getting the hallucination problem. Then we move to the pattern known as retriever augmented generation, where your knowledge base was up to date. From there we have went to the copilot stuff, where you can solve all types of problem which is happening on a everyday life. So from copilot, now we move to the agents part fully, that is fully autonomous agents, where you will be able to build any type of AI system with minimal human intervention. So that's how the agent has been evolved over a period of time, starting from chatbot till your fully autonomous agents. So today we'll be to talk more about the Azure AI Foundry. In that we have agent services, which is the Azure AI agent services. So before we deep dive into the Azure AI agent services, first of all we should know what is an agent first. So agent, it is one of the smart microservices where it is going to answer all your FAQs as well as RAG related operations. If I want to perform any type of action, and also if you want to automate all your workflow related activities, you can create your own agent. So how this agent it is possible to achieve within the Microsoft Azure platform is with the help of this Azure AI Foundry services. We can create our own agents and we can play the agents around with the different types of tools. So when I say about different types of tools, you can get the data sources from your tools section. So there are two tool sections that are available in your Azure AI agent services. One is the knowledge tools. The another one we call it as the action tools. So we will discuss these two tools in the upcoming section. So this is the Azure AI Foundry. In this Azure AI Foundry, if I want to create your own agent services, first of all, you have to create a Azure AI Foundry hub. The hub you have to create it first. From the hub you can create your own Azure AI project. For example, let me show you the Microsoft Azure AI Foundry. So I have already provisioned the Microsoft Azure AI Foundry services. In the Foundry services, first I was creating the Azure AI hub. So from the hub you can navigate to the Azure AI Foundry platform. So this is the Azure AI Foundry platform. So inside this Azure AI Foundry platform, you have to create a Azure AI Foundry project first. So after the project has been created successfully, you are supposed to deploy a model. When I say the model, almost today, if you notice that in the model catalog, we are having 1930 models are available up to date. So these models are not only from the Azure platform. There are models from your Mistral, your Llama model, your DeepSeek, all types of vendor. In this model catalog you have a quite amount of models are available. You can deploy any one of the model from the model catalogs. So what is the model I have deployed for our application is, I have deployed the GPT-4o model, and this is the one I mentioned that. So in the model catalog, we can see 1930 models are available. So the latest model O4 Mini as well as GPT 4.1. So your PyData and your Llama model, Mistral model, all type of vendor, your models are available. If I want to provision any type of Azure AI agent services, the very first part you have to do it is either you need to deploy a base model or else a fine-tuned model. So in this case, what I have deployed is I have deployed the base model. What is the name of the base model I have deployed is GPT-4o base model I have deployed it. So moving back to the presentation again. So whenever you want to create want to create any Azure AI agent services, you need to deploy the model from the model catalog which is available. So once it is completed, you have to take the two important units. One, it is your key, the second one is the endpoint. So these two are the elements you are supposed to take, and these two elements we will be using in our code section. So that's all about your Azure AI Foundry and the related model catalog. So from the model catalog, what I'm going to do is we will be using the service which is known as the Azure AI Agent Services. So what is the purpose behind this Azure AI Agent Services? There are two ways we can create this Azure AI Agent Services. One, with the help of this Azure AI Foundry, you can create a Azure agent services. The another one, if you want to create any Azure AI agent services, you can deploy this through your coding experiences with the help of the Azure AI Foundry SDKs. So using these two methodologies, you can create your Azure AI agent services. And using this Azure AI agent services, there are almost we have quite amount of components available. When I say the components part, you have a model has to be placed. When I say the model can be your model catalogs from the model. It could be your Llama model, GPT-4o model, GPT 4.1, any type of models from the model catalog. So when it comes to the data part, you can take the data sources from the local file, or it could be your enterprise solution related Bing search, your file search, your code interpreter, or even the data from the SharePoint. So any type of enterprise related data, you can take it, and followed by you can have your own storage. The storage could be your Azure Blob storage. So that is from the storage section. So when it comes to the security part, by default, this Azure AI agent services has the content safety services. The content safety services, it is going to be deprecated in over a period of time till 2025. You will be able to use it. Afterwards, there is a new service which is already in place. We call it as content understanding. So in order to ensure the security part as well as the privacy and compliance purpose, we will use the enterprise related security with the key with uh, keywordless authentication. And I say keyless authentication. So every services which are there in your Azure AI Foundry, it has been generated with a key associated with the 30 days. So every 30 days once, you have to ensure that the key has to be regenerated to avoid the security breaches. So these are all the overall elements how you are going to deploy a Azure AI agent services. So using that Azure AI agent services, there are three major reasons behind why we are using the Azure AI agent services. One is the reason is automatic tool handling. So when I say automatic tool handling, so we have two tools available. One is the knowledge tool, the another tool we call it as action tools. So these tools, usually we have to invoke these tool. If you want to call these tool, every time we have to call manually. So rather than you calling it a manually part, so now all these tool handling, which is now taken care by the server side components. So you don't need to do any calling these particular tool. This tool will be automatically called. When I say tools, both it includes the knowledge tools as well as your action tools. And the second important reason why we are using the Azure AI agent services is you are going to manage the data in terms of a thread based classification, not in terms of any conversational state. So all your data, how we are being managing is with the help of a thread, not in terms of your normal state flow method. So we will be using thread management in the security as concerned. The last one is out of box model. So it's not only it is having the Microsoft related models, it is also having the other vendor models also. Your Azure AI agent services has been supported. So these three are the major reasons why we are using Azure AI agent services. So when it comes to the component, as I briefed earlier, the very first one is your model section. So model section, all your models till your 1930 models, which are there in the model catalog, it is able to support your Azure AI agent services, and it has a wide, extensive amount of tool set. So what are tool set we are having? It is the tools related to knowledge as well as the tool related to the action tools. So when it comes to the knowledge tools, we are having the data sources from the SharePoint, Fabric data, your Azure AI search, Bing search, or even your local data, your code interpreter. All these tools are related to knowledge only. And the last set of tools, we call it as action tools. Action tools, it could be your no code, low code application like Azure Logic apps, or it could be OpenAI specified tools, which includes your serverless computing of your Azure functions. So these are the actual components which are related to the action tools as concerned. And you can bring your own storage unit or a storage devices, or as enterprise ready storages like a blob storage, or else it can be your Azure file search. So different type of storages you will be able to bring it on your own part, which is you bring your own device in terms of storage unit. So these are the actual components which is used to create your Azure AI agent services. So usually how this agent is going to work in terms of this Azure AI agent services is user is going to write a prompt or is going to craft a prompt. So in this case, I want to book for a nice travel trip, and the user wants to fly from next Monday and he has to return back on Friday. So this is the actual user query. So now user is approaching one of the agent. The name of the agent is known as travel booking agent. So the travel booking agents, he has to know about the three important things. One is the model. The second one is the tools. When I say tools, it is a knowledge sources. And the third one will be your actions. So action, it could be a local actions or it could be your Azure function related actions. Model could be any of the models from the model catalog, or you can use any of the sources which are available for the travel booking agent. So these three important things the user travel booking agent ideally require. If you notice what are the steps this travel booking agents has to be performed internally, there will be a sequence of steps will be available. So what user they will be doing in the first part is the user will be creating an agent. So in order to create an agent, you have to deploy a Azure AI Foundry hub. From hub, you have to redirect to the project. In the project, you can create an agent. Once the agent has been created, so you will be creating one of the model which are available in the model catalog. After the model has been deployed successfully, so you can automatically create an agent. So agent name by default, it will be provided. You have to rename the agent. And every agent, it is now associated with the agent ID to retrieve which agent the code has been executed. So once it has been done internally, the agent is creating a thread. So once the thread has been created, you will be able to run the agent with the help of running the agent. Once the agent has been run successfully, you will be getting the status as run status as successful. Sometimes you will be getting the run status as failed also. So why it is fail in a sense? The quota limit for your respective Azure AI model will not be available, or else you have to increase the quota limit. So in these cases, your run status will be failed. And the last, can get the response in the agent playground itself. Let me show you that. So what I'm going to do is this is my one of the documents. So what is the name of the document? We call it as the expense policy related document. So this whole document I'm going to upload to an agent. So let me show the agent. So what does the agent I have created? So I have already created one agent. The name of the agent, we call it as expense agent. So let me show the agent from the agent playground. So this is the agent playground. What is the agent I have created as expense agent I have created. So every agent is now associated with one agent ID. And what is the tool I have uploaded here? If you notice this, I am uploaded a local file. Okay. And what is the model I have deployed is GPT-4o model I have deployed it. Just I'm going to utilize this agent. So I'm going to open this agent in the playground. So let me ask questions like, what is the maximum amount I can claim for meals? Okay. So for the meal section, the maximum amount I can claim it is $50 per day. So that is the response I was supposed to expect from the agent. So what is the maximum? What is the maximum I can claim for meals? So this is the prompt I just provided to the agent. Now agent will hit the model. The model will start checking the file. So which file, you can see that maximum you can claim for meals is $50 per day, and you can notice the citation. The citation here says so one, which means it has taken the data from the uploaded document. So in the uploaded document, you can see what is the file, what is the expense category, what is the type, how much amount you can claim for various activities, travel this much, accommodation this much. The entire file, it is getting the citation value, which is nothing but grounding the data to the local context. So this is related to your knowledge tool section. The other one, I'm having one more input data. This is the next input data. So in this input data, you can see there is one CSV file I'm having it, which is nothing but the sales.csv file. So from the sales.csv file, I'm going to query some of the values from the sales.csv. So for this, I will be using one of the tool known as code interpreter. Okay. So let me use the code interpreter tool. So in the agent section, instead of the local file, this time I'm using the code interpreter. So under the code interpreter section, so we will be able to query any type of CSV file which have been uploaded. And this code interpreter has its own default sandbox Python editor will be available. So I'm going to query those one. Let me query it. Now it's loading the code interpreter section. Meanwhile, time. So what are the columns available in the sales.csv? We have a region, item type, then order priority, units sold, unit cost, total revenue, total cost, total profit. So let me ask the query to the code interpreter saying that which region is having the highest number of units sold. Okay. If I prompt this, let me type the question, which region is having the highest number of units sold. Suppose if I type this prompt, now it is going to hit the generative AI model and it will call the code interpreter section. In the code interpreter section as a default sandbox Python environment, it will perform the data analysis package with the help of the pandas package. And internally, it will call the group by functionality of pandas. So you can see this. So using the code interpreter, it is defaultly called the Python-based environment, and one of the famous data analysis package is the pandas package. Using that, it is saying the result as, see this. First, it is loading the entire data set. Then afterwards, what are the columns available? And based upon the columns, what is the question I asked is, what is the which region is having the highest number of units sold? So it is automatically performing the aggregate function with the help of group by class inside the pandas package. And finally, it has been computed this particular result. In case I want, what is the code? Give me the code to perform this. I want to do this code. What is the code? It has been performed. This operation. Let me ask this question. It is going to provide the entire Python code to me now. See? The read.csv, and it is given the group by class. So you can execute this code in your Python based shell and you can execute this particular code. Same way, if I want to write any data visualization, I want to do some data visualization, create a bar chart. So create a bar chart for the item type versus units sold, right? What is the column name I have? Units sold. Let me ask a bar chart to create it. So now this is going to create a bar chart for the item type versus column versus your units sold now. So this will call the matplotlib as a primary library and it is giving the result. See the result? The wonderful bar chart has been given inside the agent playground itself. So earlier agents playground, we are having something named it as assistant playground. The only one thing in the assistant playground, we can play around with only with the Azure OpenAI model. But in the agent playground, you will be able to play almost 1930 models. You will be able to play it. So these are the various types of agents playground. So let me move on to the next one is what are the options we can develop the agent developments. As we already seen that Azure AI Foundry will be able to develop the agents. If I want to develop multi agents, then I can use AutoGen framework. But AutoGen framework, it is not useful for your production ready application. Is only for the ideation purpose, that is autogen. But if I want to do both for ideation as well as production ready related operations, then you can prefer the semantic kernel. Okay, so let's see the semantic kernel deep dive. Semantic kernel, if you've seen that, it is one of the open source SDK and you can create your own agents with the help of semantic kernel. So how it is possible to create your own agent with the help of semantic kernel is you can use the existing large language model from the model catalog, and user can write and user can create their own agents with the help of semantic kernel. The only three essential information we need from the semantic kernel is one is the deployment name, second one is the keys, and third one is the endpoint. So these three are the essential information we require from the semantic kernel. And look around this semantic kernel is now supporting almost all type of languages. It supports c#.net, it supports Python application development, Java application development. So these three languages is now supported for your production ready application in terms of semantic kernel. And the next one is what are the endpoints the semantic kernel usually support? It supports OpenAI endpoint, Azure OpenAI endpoint, your Hugging Face, Mistral, your PyData, all types of endpoint your semantic kernel is supported. If I want to deploy an application from a Hugging Face, then I can take the Hugging Face endpoint. If I want to deploy Azure OpenAI endpoint application, then you have to take the Azure OpenAI endpoint. So whichever application you want to deploy it, you can use the endpoint accordingly. So let's discuss what is the difference between the Azure agents versus the Azure OpenAI agents. When you go for the Azure OpenAI agents, it is only supporting the Azure OpenAI endpoint. It is not supporting other endpoints. But this Azure AI agent, it has flexible model selection. What does the meaning of flexible model selection is? You can take and you can deploy any of the models from the model catalog. That is flexible model collection. The second one is extensive data integration. It is supporting too many data sources, SharePoint data, your Fabric, as well as your file search, Bing search, code interpreter, local files. So all type of data integration it is supporting. And also it supports enterprise grade security. When I say enterprise grade security, which is your keyless authentication, all the keys are encrypted in your enterprise grade security. And you will be able to choose your own storage solution. Meaning of own storage solution is your Azure blob storage. You can bring your Azure blob storage, you can use it inside the Azure agents, or also you can use your own file index also inside the storage solution. So these are four major reasons compared to Azure OpenAI. Your Azure agent is best. So, what is the major reason we were using the semantic kernel for the production ready application is it allows the streamline integration. The meaning of streamline integration is any type of enterprise product, any type of enterprise model it is able to support inside your semantic kernel streamline integration. That is the first reason. And the second reason is you no need to learn the entire API end to end. You just use the API as it is, which helps to reduce your overall learning curve. And final one is all the control with respect to this semantic kernel development is in the user hand in terms of the extended reliability as concerned. So these three are the major reasons why we are using semantic kernel in order to develop any agents. So let me show you the semantic kernel agents before I'm explaining the architecture. So this is your code which is related for your semantic kernel agents. So what is the first one I have done here? It is under the semantic kernel is first of all you have to install the package of semantic kernel. So how do you install the package of semantic kernel is using the .NET add package command, you will be installing the semantic kernel. Once the semantic kernel has been installed, you can check here inside the CS project folder. So under the CS project folder, you can see what is the package I've been installed is Microsoft Semantic Kernel. So Microsoft Semantic Kernel is a package and which version I have installed is 1.3.0 version I have installed. So you can install the latest up-to-date version also. And second package, what I have installed here is Semantic Kernel Core Plugin package. So we have different types of plugin which are there in your semantic kernel, like your HTTP plugin, time plugin, conversation summary plugin. So close to 9 plugins are available. If I want to use those functionality, then I have to use the core plugins package. So these two are the packages you are supposed to install. Then one more question is, in order to use this semantic kernel code-based development, you need a Visual Studio Code first. The Visual Studio Code editor is a free editor. You can download it from the internet itself. The second one is after you have downloaded this, the second prerequisite you require is you have to download the .NET SDK. So .NET SDK framework you have to download. Then once these two stuffs has been completed, you can download the packages. One is the semantic kernel package and the second one is the plugins core plugin package. So these two packages you have to download from the internet. So once these two has been downloaded, let me explain the architecture section. You can see this. So under the semantic kernel architecture, we are having three important core components are available. One is the model, second is memory, third is the connector, and the fourth one is plugin. So these four are the major components which is going to form your semantic kernel. One is the model. When I say model, model can be from your model catalog. Almost 9,930 models are available, right? From the models, you can deploy either a base model or else your fine-tune model. You can use any one of the model. And connector, if I want to use the OpenAI application development, then use OpenAI connector. If I want to use any Azure OpenAI, use Azure OpenAI connector. If it is a Hugging Face, use Hugging Face connector. So from the connector, you will be taking two essential information. One is the key, the second one is the endpoint. And third, we can call it as the plugin. So the meaning of plugin is a class which consists of a functions where your kernel is about to execute. So when I say functions, it could be HTTP, it could be a time plugin, it could be a summarization plugin, or it could be a conversation plugin, or it could be a file IO. Any type of plugin, you can make use of it. So the plugin can be a built-in plugin or the plugin can be a custom plugin as well. So this is one of the core component in your semantic kernel. The other part, if you notice from the semantic kernel, which is called as memory. The meaning of memory here is if I want to provide any context management for your API, like your vector DB, your embeddings, or else even it could be your Azure Redis cache or Azure. Then in that cases, you can use your memory for your abstractions of the context management. And the last one is your triggers and actions. If you want to perform any one of the plugin you are using inside the semantic kernel, and you want to execute those plugin, then you will be getting a final result in your console application, or it could be a web-based application with the help of your actions and triggers. So this is your overall architecture of your semantic kernel. Let me explain the code section now. So this is the actual code section. So what is the code section I mentioned is you need to install the VS Code, then you have to install the .NET Core framework. Then afterwards, you have to go to the Microsoft Azure platform. In the Microsoft Azure platform, you require a subscription. Inside the subscription, you have to deploy one Azure OpenAI services. When I say Azure OpenAI services, use the compactable model. It could be your GPT-4o, 4o mini. Use always a compactable model where you will be able to execute a semantic kernel application. So this is your prerequisite. So let me explain the code section now. So under the code section, if you've seen this, the very first code is I just used the semantic kernel package under the uh, package section. So afterwards, here we are having one of the static method, which is nothing but a main method. So inside the main method, we require one of the kernel object has to be created. So before we creating any kernel object, we have to use a builder object first. How will you create a builder object? In order to create a builder object, you require one of the interface called it as kernel interface. Kernel is an interface, and you will be using a method known as create builder. So create builder is a method which is going to instantiate all your kernel objects. So here, which connector I used is I have used the add Azure OpenAI chat completion connector. So inside this, I passed three important parameters. One is the deployment name. So what is the name of the deployment? Which is GPT-4o. So you can check out which model I have deployed. I have deployed GPT-4o. So this is a model I have deployed. So same deployment name I have taken. And you have to pass your API key and endpoint. So here I passed for this particular session, I used the API key directly. But using the API key directly is not advisable. It is always well and good. You keep your API key inside a key vault function. Then API key and endpoint. These two essential information you can take from this here. So key is there as well as your endpoint. So you take these three essential information, and afterwards I'm going to build the kernel object. So build.kernel. So kernel object has been built. Then for simple example, I use this. So I'm using one of the method known as await kernel dot invoke prompt async. So this is the actual method where I'm going to pass my prompt now. So what is the prompt here I have passed is give me a list of breakfast foods with the bread and cheese. So this is the prompt I passed inside the invoke prompt async method. I just executed this code. How do you execute this code is .NET run. What is the name of the file? The name of the file you can put it. So now this will be calling the GPT-4o model along with the key and endpoint, because this two keys and endpoint should be active. Then only you will be getting the result. So usually this type of questions we will be asking in the agent playground or in the chat playground. Can get the result. That is one way of creating an agent. The other way of creating an agent with the help of the Azure AI Foundry SDKs. This is the Azure AI Foundry SDK. So through your semantic kernel SDK, we are creating these agents. Now it is going to connect with your GPT-4o model along with the endpoint and along with the key, and whatever the prompt you are given, it is going to hit this. So you can get the list of breakfast foods. So we can get the answers like grilled cheese sandwich, cheese toast, breakfast, then cheese bagel. Then we have almost how many items are along with the breakfast with the cheeses? 24 items are available. So let's deep dive into the other part. Like we are having several built-in plugins are available. And I say built-in plugins. So So we are having HTTP plugin, text plugin, math plugin, conversation summary plugin, time plugin, wait plugin, file IO plugin. So any file related operations, I can go for file IO plugin. If I want to wait for a specified number of milliseconds, then I can go for wait plugin. So this is for time related operations, and this is for mathematical operations, text to manipulation for text plugin. And if I want to make any HTTP request, then I can go for HTTP plugin. So conversation summary plugin is nothing but for any conversation summary, I can go for conversation summary plugin. So let me show you one plugin example. So for plugins, you are supposed to install which packages your semantic kernel plugins core. So this package you need to install it. So this package, how do you confirm that the package has been installed successfully? You go and check the CS project file. So here you can see this Microsoft Semantic Kernel plugins.core. So this plugin has been installed successfully. So I use the alpha version. So alpha version in the sense you will be getting some of the warning messages. You need to suppress those warning with the help of pragma. So pragma is one of the value where you will be going to suppress all these warnings because it is in the alpha stage. So what is the name of the function I have created here is my time is the name of the function I created. Same, your builder object is same, and your deployment name, your key endpoint. This is from your Azure OpenAI. I have taken this. Then since I'm going to use as a time plugin, I have to use pragma warning disable. So this is the warning error code information. I have to put this. So how to call your time plugin is with the help of builder object. So builder dot plugins. There is a function, name it as add from type. So using the add from type collection, you will be calling the name of the plugin. What is the name of the plugin here? It is time plugin. Then using your kernel object, you are building the entire builder. Then finally, with the help of this invoke async, I'm passing name of the plugin. What is the name of the plugin is time plugin. Then I pass one of the function called in the time plugin is day of week. Then I just executed current day. So what is the static method I have created is my time is a static method I have created, and the name of the class name it is known as program 001. So what I will be doing is I'll go to the main functionality. So in the main functionality, I will be invoking the method. So how do you invoke the method is avoid. So avoid is a keyword. Then what is the name of the class? The name of the class is program 001 is the name of the class. So I have given it. And what is the name of the function? The name of the function is my time. So I have given the my time. So let me execute this code. .NET run name of the class. So it says Wednesday. Today is Wednesday. It is given that. Similarly, let me explain some of the other plugins. So we are having one more plugin. Let me explain it as the conversation summary plugin. So for the conversation summary plugin, same thing. I have taken two packages, semantic kernel package, semantic kernel's plugin core package. Then inside the builder object, we passed deployment name, API key, endpoint, and we suppress the pragma error code. Then this time in the add from type, we'll be passing the plugin name it as conversation summary plugin. So now I have given one conversation. So what is the conversation I have given is, I am a vegan in search of new recipes. I love spicy food. Can you give me a list of breakfast recipes that are vegan friendly? So here I have given some constraints. So from this constraint, I'm going to call this invoke async method. What is the name of the plugin? I have given the name of the plugin. So one of the actions in this conversation summary plugin is get conversation topics. So what is the meaning of get conversation topics? So this is the actual input. From this input, what are the conversation topics we are having? Vegan is one of the conversation topic. Spicy is one of the conversation topic. Your breakfast recipe is one of the conversation topics. So these are the conversation topics is available from the existing conversation. Then how we are achieving it is with the help of conversation summary plugin, we are achieving it. So for this entire execution, I created a method name. It is known as my conversation. Let me call this my conversation in the main function. So let me call it as await the name of the class followed by the function name. So let me execute this .NET run program. So this is going to pick the conversation topics from the existing conversation. So this is going to print a JSON object now. See the topics. Vegan is one of the topic. Recipes is one of the topic. Spicy food, breakfast. So these are the topics it is picking from the main file. So the last two topics are one, I'm going to explain the prompt template as well as how to deal with the persona type. So let me explain the prompt template first. So this is a prompt template. You can see this. So I have given some of the prompts saying that you are a travel assistant. You are an helpful, creative, user friendly. So I specify the language as French in the curly braces. That is a expression language. So from this prompt as well as from the history. So what is the history I provided here? It is I am traveling with my kids. One of the kid has a peanut allergy. So here I have a past history. So past history I have given, and also I have provided the language also. Then I have given the prompt template in terms of the expression language, that is a curly braces. So from this you are expecting to print a travel assistance. You are asking user friendly dishes, and one of the kid is having the peanut allergy. So this is the actual constraint I'm giving. So you are asking the assistant to suggest, so what are the helpful and useful phrases if you are having these type of allergy conditions. So you are asking such type of question. Let's see the response. So I just execute this code. So how, in which format it is going to print is English hyphen followed by in French statement. So it is going to print in this way, and how to pronounce this in French. So that is, it is going to provide for all useful phrases if you are traveling to some country. So which country I'm traveling here? It is France country I'm traveling, and I want English to French translation. So that particular prompt it is going to display here. You can see this. Hello is bonjour. Hello is English. Bonjour is in French. Merci beaucoup is your thank you. So you can see the basic greetings and information, getting around. So these are some of useful phrases. For shopping and restaurant, you can ask in English. This is in French and how to pronounce this. And for emergencies, for numbers, times and dates. So these are some of the helpful phrases which will be used in the prompt template. The final one, it is the how to use this prompt inside the persona. Okay. If I want to use prompt inside a persona, let me comment this. Let me show the last code. So this time I have given with the prompt with along with the persona type I have given. So this time I don't want any type of information, like you are not asking. So earlier in the prompt template, it is not suggesting that whether it is helpful or it is useful. So such type of system messages were not there in the prompt template. But when you are going for the prompt with the persona type, so whatever the suggestions provided by this semantic kernel SDK, it is going to ask like a begin with like whether it is you may be able to helpful, and it is going to end with I hope this helps on your trip. So such type of system messages you are based upon different type of persona type. So here the persona type is traveling. Sometimes you may be using for assistant related questions. Sometimes you may be using for system related questions like finance or retail or manufacturing. So different type of persona prompt we can be suggesting with the help of this one. Let me execute this. So this time I'm going to type .NET run program. So it is going to start with some system message, and it will give some responses, and it will end with some system messages. So that we call it as a persona types. See, in the initial time, it says here there are some phrases in French you might find helpful. This is one of the system message. So we got some responses. Okay, but this time it is giving some food allergy awareness. That's one of the phrase. So what are the in English and what are the statement in French? Along with that, it end with I hope this helps you on your trip. Safe travel. So such type of system messages persona type is printing for travel booking agent assistance. So that's it. So Parth, over to you for questions. Parth, hello.
Yes, Janardana. Okay, so he asked like, is there a way can we get the deck of this presentation? The session is already recorded. You can come back and look at it anytime.
I will share some of the learning resources also. That will be helpful
I
for you.
have the resources that you sent. I have already shared
Yes.
it, but anything apart from that, please do share. I'll paste it here. Yeah. So there's another question asking like how to deploy and publish agents created in AI Foundry in third-party apps as chat interference.
So you can use your model catalog. Inside the model catalog, you can use any of the third-party interfaces with the help of the N89 is one of the famous framework. And also you can use LangChain and LangGraph for third-party assistance.
So Tariq has a question here asking what is the difference between creating Azure AI agent service or Copilot Studio AI agent?
This is an interesting question actually. So both are creating an agent. When you go for the Azure AI agent services, it's completely the code-based development. But if you want to go for a Copilot Studio agent creation is your low-code application. So code will be less. It's not more. And that is especially for the business users, Power Platform business users.
Yeah, kind of prompting.
Yes.
So, any more questions? I hope that answers the questions. Final call to ask your questions. Okay, so Umesh has a question asking like there are terms Azure OpenAI SDK, Azure AI Foundry SDK, Azure Model Inference API. Are they part of Azure Agent Service? What's the difference? So, yeah.
There are terms like Azure AI Foundry SDK and Azure OpenAI SDK. So these are the actual SDKs to make your agent application development. And if you want to compare the differences, then like how much time it is going to be executed, what are the other factors it is going to check, like a model benchmarks. So those things you can check in the model interface API. So that is going to provide you whether it is a serverless application or it's not serverless application. So how much compute instance you have been used and how much compute instance you have been saved. So those type of model benchmarks, which type of code are you executing in the model interface API, you can check that. Like how much of CPU, how much of GPU, the storage, the compute, your serverless computing, which functions you have been used, all your model benchmarks you can check in your model interface API using the Azure AI Foundry SDK as well as Azure OpenAI SDK.
I
It
hope
is
that's answer
where
answer.
he is asking this question. Just a second, Parth. So when you open the models, for example, in the model catalog, there is an option we can see model interface. Okay. So whether in which model it has been developed, how much computing time it has been taken. So those model interfacing pipe you can check out when you are deploying any model. I think I hope I answered your question.
Yep, I think so. And so there is a continuous by Tinsel asking, I want to know that way we can publish
How to
agent
publish
from Copilot.
Copilot in TCP? Okay. That
Yes,
is
I
your
want.
declarative agent. There is a concept called it as a declarative agents in the Visual Studio itself. You can directly deploy your agents in the Microsoft Teams platform itself. That is using M365 applications.
Okay, for that we have a separate series running called as Copilot Chronicles. Please, every Thursday 3 to 4, 4:30 to 5. Please do visit Copilot Chronicles. For that you need to visit Reactor Meetup page, and you can learn more there. Yes, and one final slide I'd like to share you is we have a lot of discussions going on Azure AI Foundry, and please join and stay connected with the Microsoft AI community. And please do scan the QR codes, join the discussions, share your thoughts, have a great learning. And yes, Jonathan, I don't see any more questions coming up, so can we call for a wrap?
Yes, Pat. Thank you so much, everyone. You're taking your time and effort to participate in this session. We are looking forward for the upcoming series. Please do participate. Please do visit our Microsoft Reactor Meetup page as well as Microsoft Reactor Bengaluru YouTube channel also. Please, we will post all the YouTube in the channel videos also. And thank you, Parth, for providing me this opportunity.
Thank you everyone for joining us today. Thank you, Jonathan.
Thank you so much. Thanks, everyone.